So this is just a follow-up video to the LeetCode Problem 1 solution, which I posted a bit earlier, where I showed off my brute force solution to the coding question. So I wanted to do a follow-up video because I wanted to explain how I got to the n squared time complexity for my solution. So it's very similar to thinking about how we get n squared time complexity for two nested for loops, where we loop through the entire array twice. And I'll start off my explanation by using that example. So let's say we have an array, which I'll call nums, and I'm going to use E1 to denote the first element. So E2 will be the second, E3 will be the third, and so on until we get to the nth element. Now, if we have a nested loop, so two nested for loops where we loop through every single element exactly twice, what we end up having is for every single element, so for the first element, we're going to then loop n times, so through every single element, or all n elements. Then once we get up to the second element, we then again loop through every single element n times. So for the first element, we have n. Second element, we have n. Third element, we run through it again n times, and so on until we get to the very last element, which is en, where we then again run through the entire list one more time. And this, there are n different times where we have to add n. And as you can see, if we add n to itself n times, we have n times n, which is n squared time complexity. Now, my solution isn't too different. It uses, again, a nested for loop, which is very similar, but it uses a bit of a different technique. So if I write out nums is equal to E1, E2, E3, and so on, my solution doesn't exactly loop through every single element twice, because when we first look at the first element, I'll use a green pen now. There we go. When we look at the first element, I'm not then looping through every single element in the list, so all n elements. Instead, I'm looping through the second element to the nth element, because I'm looking at every element after the first element. So there are n-1 elements in this case. So we have n-1. Then when we get up to E2, I'm looking at E3 all the way up to En, which is now n-2 elements. And you can probably see a bit of a pattern here. Every time we move to the next iteration of the first loop, we're decreasing by 1 for how many elements we look at in the nested loop. So this time we look at n-3, then the next one we look at n-4, and so on, until we get up to the nth element where we look at n-n, which is just equal to 0. So I guess we can cross that out. Now I'm going to rewrite this, but instead of looking at it in a decreasing order, I'm going to look at it increasing. So we can start at 0, but I'm going to start at 1 because we know the addition of 0 doesn't change anything. So 1 plus 2 plus 3 plus ... all the way up to n-1. And what we can see here is that we have a simple summation. So there's a formula for this. This is the sum of the first n natural numbers. And the sum of the first n natural numbers, let me write that over here. Let me denote it as Sn, is equal to n times n plus 1 all over 2. So in this case, this isn't the sum of the first n natural numbers. This is the sum of the first n-1 natural numbers. So the summation of this is equal to n-1 times n-1 plus 1, because I'm substituting n-1 here in for this n. A little bit confusing that I'm using n in both cases, but hopefully that does make sense. But then this over here becomes n all over 2. And as you can see, if we expand this out, we have n squared minus n over 2. And when we look at time complexity, we ignore constants, so we can ignore the 2. And then we also look at the highest power. So we have n squared minus n to the 1, so we can ignore the n to the 1. So we're left with n squared, and that's how we get our n squared time complexity.